Yeah, good morning. My name is Dr. T.S. Srinivas, working as Associate Professor in Department of CSC. So today I'm going to discuss about the ER diagrams. ER diagram stands for E stands for entity, R stands for relationship. So what is an entity? What is the attributes? What are the different types of relationships between the entity and attributes? Entities and entities, the relationship between entities and attributes, and what are the different relationships. So these are the course objectives. Understand the fundamental concepts of DBMS and DBMS architecture, analyze the data models and apply normalization techniques, develop SQL queries to retrieve, manipulate, and manage the data effectively, and demonstrate knowledge of transaction management and apply DBMS concept to solve the real world problems using modern database tools. So these are the course outcomes. Explain the basic concepts of DBMS, evaluate the database models, apply the architecture to the databases, and design the databases using the ER model. So our ultimate goal in the database management system is the evaluation and analysis and design of the database models using the ER diagrams. So these are the different syllabus in the unit 1. So today I am going to discuss about the ER diagrams. ER diagrams, entities, attributes, and entity sets, and relationships and relationship sets. These are the topics I am going to discuss in the unit 1. So these are different textbooks we have followed. Sudarshan, first one, and database concepts by Navate and Ramakrishnan. So what is the ER diagram? ER diagram is the visual representation of the database. So what do you mean by visual description? So whenever we are going to describe about the entities are described. This is the symbol for entity. This is the symbol for entity, and this is a symbol for attributes. And between an entity having the different attributes, so these are all different attributes, and all the attributes are derived from these entities. So this one attribute. So we are having 4 attributes. So an entity is having the 4 attributes, and the entity is having the 4 attributes, which shows the entities, attributes, and relation ER diagrams. So during the design phase and during the analysis phase, we are going to analyze this attribute, analyze this entity, and analyze different attributes of that particular entity. So what is the purpose of the ER diagram? Purpose of the ER diagram is to understand the data requirements. So when we are going to design the database, the database consists of the entities, the database consists of the attributes. So what attributes we are going to take in that particular entity, and what attributes we are going to take in another entity, and what is the relationship between the 2 attributes. So if I am having an entity called student and employee, what is the relationship between the student and employee? Okay, so an employee taking class for the student, employee teaches a lesson, employee takes a course. So taking a course is a relation between the 2 entities. So like that we can have a relation between the 3 entities or 4 entities and more than that. So by doing this entity relationship diagram, we are going to understand the structured database. Structured database means here we should understand what is the weak entity, what is the strong entity, what are the different key attributes, what are the different keys we are going to take, what are the different multi-valued attributes we are going to take. So all the relation, all the attributes, all the different types of entities that you are going to use, that we are going to represent in a particular diagrammatical format. So by representing that in the diagrammatical format, we can reduce the redundancy. So suppose we are having one particular attribute which is represented in different entities. So we can remove that particular attribute. So redundancy can be removed, and the data consistency is maintained. How the data consistent? Definitely by removing the redundancy, the data consistency will be maintained. So by doing this design aspect, we can understand that there will be a communication with the stakeholders. So what is the stakeholders here? Who are the stakeholders? The stakeholders are those persons who are going to use that particular database. So when we are having a clear explanation or clear imagination of what are the entities and attributes that you are going to take, so definitely there will be a clear imagination and a clear communication. We can easily communicate with the stakeholders. So the basic components of the ER diagram are entities, attributes, relationship, cardinality, constraints. So we'll discuss one by one. So what is the entity? Entity is a real world object. So I am taking one entity which is called the student. So student is a real world entity. So next one is employee. Employee is a real world entity. So they are represented by a rectangle. Okay, they are represented by a rectangle, and we are also having a one more entity which is called as a course. So these are all different entities that we are going to have in our particular discussion. So these entities that we are going to describe, this can be a physical or logical. So physical means here physical student is a physical entity. Logical means student is a table. So in the table, in the logical table, we are having the different attributes. So one of the attributes we can specify as the primary key. So I'll discuss what is a primary key and all those things. In the previous discussions, I've discussed what is a primary key, foreign key. And for each and every table, it is a mandatory to have a primary key. So we cannot design a particular database table without any primary key. So these are all different types of entities. One is called as a strong entity, weak entity, associate entity, and these are all. So what is strong entity? Strong entity means if all the attributes, strong entity is represented like this. This is entity and this is a strong entity. The meaning of strong entity is all the attributes of that particular entity are going to participate in the design process. So all the attributes are going to have the data, and all the attributes are going to participate in the relation with another entity. So here I am having a relation. Relation is expressed as a diamond. So this is another entity. So I am having, you see, once again I am going to draw the diagram. So this is strong entity. This is the relation. This is another entity. So all the attributes of this entity, you see, this is the symbol we can give. All the attributes of one entity are going to participate in the design process of all the attributes of the second entity, and there is a relation between the two attributes. This is what is called as a strong entity. Weak entity means there is no primary key. So weak entity we are going to represent in dotted. So this is a dotted. Weak entity means it cannot form a primary key also. So we can represent that in the dotteds. And associate entity means different types of entities. One-to-one associate, one-to-many associate. So here you can see we are having one more entity like this. So this is the example of the associate entity. We are having a strong entity. We are having an entity. We are having another entity which is in association with the strong entity and association with another entity, and there is a relationship maintained. The same relationship is maintained between the three entities. So if the same relationship is maintained within the three entities, then it is called as the associate entity. So attributes. So entity is represented with rectangles and attributes are represented with the ovals. These are the different. So I take a student table, student ID, student name, student address, and student mail ID. So an entity, this is an entity, and these are all different attributes of that particular entity. So we can also have student age, student name, student ID, So we can specify one particular attribute of this particular attribute, and the one particular attribute as a primary key. If you are specifying student ID as a primary key, then the student ID is, this is the way of representing the primary key. So attribute followed by the, and if you just give an underscore of that particular attribute, then it means that it is a primary key. So we are having different types of attributes. One is called as a simple attribute. This is called as a simple attribute. This is called as a composite attribute. This attribute is single valued attribute. So this is entity, and this is attribute. Multi-valued attribute. This is one attribute. So this is multi-valued attributes and derived attributes. This attribute is, one attribute is derived from another attribute. So we can specify these types of attributes in 5 different ways: simple, composite, and single valued, multi valued, and derived attributes. So these are all different symbols for the attributes. So the relationships, we can maintain the relationship between the different attributes. The relationships, as I told, the entity between the entity, the relationship is maintained with a symbol which is called as a diamond. So this is the relationship. So we are having different types of relationships between the two entities. One to one, we will represent like this. One to many, we represent like this. One to many, this is one to many. One to many, we represent with star, and many to one, we represent in this way. And many to many attribute is represented in this way. Star to star. So this is many to many. So in this way, we can represent different types of relationships. So what do you mean by cardinality? Cardinality means it is nothing but it defines number of entity instances involved in the minimum of maximum participant. So what is the meaning of this particular concept? So I will define one entity. And I will define the different attributes of that particular entity. And if I say one to one, so there is a relation between one attribute of one entity to another attribute to one attribute of another entity. If I say 0, n, so relation means we can express like this. And also we'll having one more entity like this. Okay. So we can say 1 to 1. That means one attribute of entity 1 is having a relation with one attribute of entity 2. 0, 1, no attributes of one entity is having a relation with n attributes. And 1 to n, one attribute of entity 1 is having a relation with number of attributes in entity 2. That is cardinality. So what is meant by participation constraints? So this is the most important concept of the ER diagram. Participation constraints, they are represented with a single or double lines. So now you see here, if I say a relation like this, then it is represented with a single line. So the meaning of single line is all the attributes of entity 1 and 2. I represent all the attributes of entity 1 and all the attributes of entity 2 are having the relationships. So that is called as the total participation. So all the attributes are having the relation. So we can derive the relation statements of entity 1 and entity 2. So all the attributes of entity 1 are having relation with all the attributes of entity 2. That is called as the total participation. Partial participation. Some of the attributes of entity 1 are having the relation with some of the attributes of the entity 2. That is called as the partial participation. So what is a weak entity? Weak entity, it has no primary key, as I told. It has no primary key. So how we represent the primary key? I told this is a way of representing the primary key. So I take the student table, student ID. This is the primary key. So student ID and with underscore. If you represent that in that way, then student ID is the primary key. And these are all different attributes. This is the primary key. So a weak entity is that entity where there is no primary key defined. And also it uses the partial key. Partial key, how it is going to use? It is uses the partial key of the other particular entity. So this is weak entity which is represented with a double rectangle. Strong entity, weak entity is represented with double rectangle in dotted lines. Okay? This is the dotted lines. Strong entity is represented in double lines with the thick lines. Weak entity is represented in this way. One more rectangle. This is a way of representing the weak entity. So advantages by doing this ER diagram, we can easily understand, we can better database design and the visual clarity. This is the topic which I want to discuss today, that is ER diagrams with strong and weak entities. So in the next presentation, I will be discussing about the different types of relations and relation sets along with the additional features of the ER conceptual design. Thank you.